I'm Mindy Todd. Welcome to The Point. Research and development into improving the energy efficiency of buildings and appliances is ongoing, as is the development of technology that allows for new and different ways to decrease energy consumption. Today, we talk about some of the ways we can reduce energy consumption in both new construction and in older homes. Joining us is Roe Osborn, senior editor at the Journal of Light Construction magazine, or JLC. Welcome back. Good to see you.
Hi, Mindy.
And also with us is Steve Baczek. He's a registered architect in Massachusetts who specializes in energy efficient and environmentally responsible homes. He's also designed several passive solar homes in New England. Welcome. Good to see you.
Good morning, Mindy.
So, Ro, when we called you to talk about doing a show on green building technology, you immediately said, oh, you have to talk with Steve.
Yeah, Steve.
He's designing and building these passive solar homes. So, yeah.
Steve understands more about the building science behind this new technology, that's sort of where it all has to begin. He understands it better than anybody I know, and I've been lucky enough to work with him on a couple of articles involving various facets on it.
Yeah. So, Steve, let's start with the penultimate of green building, the passive solar design. You've designed two in Falmouth and another on the Vineyard. Can you explain the principle behind passive solar design?
Yeah, it's actually very simple. Passive House Standard dictates a set of parameters that yields a house that's about an 85-90% reduction in energy use.
And so when you talk a little bit how you sell this to people, because people, when you're building a house, you have a certain budget, and I think cost is always a factor. People always go, well, how much is this going to cost me?
Cost is always a factor, and they run the gamut of the spectrum of housing, just like code-built housing would, that you have your expensive houses and you have your more modest houses. I've done a passive house in Rhode Island that came in at market rate for a homeowner. So, we can do it at that level. But, in selling it to the clients, although the house is extremely energy efficiency, I place a strong emphasis on the comfort, durability, and health of the house, so that if I can achieve a high degree of success in those areas, I get energy efficiency as a byproduct.
All right, so building designs that maximize the energy of the sun have been around for hundreds of years. What are some of the reasons interest in this waned, and why is it making a comeback now?
Well, it's Passive House US, or FIUS, as we call it, has just recently, I say recently, but within the last 10 years, brought this set of parameters from Germany to the United States to make a stand with it. And it has taken off overwhelmingly, that we have a lot of people getting educated in that arena and trying to adopt these principles in their projects.
Ro, you're an editor at the Journal of Light Construction, so you have your finger on the pulse of how new technology is being incorporated into buildings. We should say this is a magazine aimed at builders, so you've got all the kind of latest and greatest, I would assume. So are you seeing more emphasis on energy efficiency?
Yes, but as Steve said, it's the building techniques that go into the house, and energy efficiency comes as almost as a byproduct, but we monitor that, and we also it seems to be what people are most aware of out there. And when a builder goes into a meeting with a client, that's the first thing the clients ask about, is cost and energy efficiency. So when we're in our articles, we try to promote as much as we can techniques that are building efficient, and it's an evolving thing. There are all sorts of things involved that really turn building on its head from the way we've been building for the past 200 years. The whole idea of creating air barriers and vapor barriers in homes that I still have trouble understanding, and that's why I love talking to Steve about it, because he was like, "Oh, this is how it's done." And then once that's done, making the house itself healthy and sustainable inside.
I'm just thinking of, we've done shows as everything, the green, where we've done this, where we've gone, how green is green? What does green mean? Sometimes it's just a marketing thing, and it's not really a green product at all, and it's very confusing to the consumer. And now you're talking about how the building the technology and things are changing. And Steve, I would imagine for you, trying to educate builders and August with the magazine, trying to educate builders on what this process is and what the best practices are is also evolving. And before we went on the air, Steve, you were talking about this ladder. You've got different levels. Explain that to the listeners.
So when a client first comes to me, and most of them aren't even aware of Passive House, and we start designing the house, some of the questions that come up is, to what level of energy efficiency do we want to build? And they say, well, what do you mean? And I said, well, we can go to the top of the ladder and build you a zero energy house, so you never have an energy bill in your life again. I mean, a gentleman about a mile from here in Falmouth has one of those houses, and his house is even beyond that. He makes so much electricity that his house doesn't use. He defers 25% of his sister-in-law's electric bill.
Wow.
And, he sends it across the grid to her house and pays a quarter of her bill after he pays everything: cooking, heating, hot water, everything, and charges a car. So it's that's the higher level. But even at the lowest level, when we were talking about cost, when people say, well, how much more does a passive house cost, or how much more does a greenhouse cost? Well, the reality is you're measuring it against a house that's a code-built house, which is the least acceptable standard we can build by. So when other builders say, well, that costs extra money, well, that's because you're building the very lowest rung on the ladder. I don't care if it's $300 or $400 a foot. From a performance perspective, you're way down at the bottom of that ladder, in performance. So you need to pay attention, and there are a lot of low hanging fruit. Air leakage and just making some decisions that you have to make anyways when you design and build a house, that if you make a more informed decision, it's to your benefit. And you start climbing that ladder at really no cost, because it's stuff you have to buy anyway.
I think you just said something that people went, wait, what? The building to code is the least acceptable?
It's the least acceptable standard.
Yeah.
And that's what people measure cost of a house by. So you always hear these numbers. Oh, how people meet with a builder, how much does it cost to build a house? $200 a square foot. Okay, well, what does that get you? I don't know. It's a number we use that, that's what I can get a permit from the building inspector, and I can build that, and nobody gives me any grief, so
right.
Let's just build that. But they're not really thinking about what they're doing. And the passive house movement, while it's developing great houses, I think the strength of FIAS bringing that set of parameters to the United States is it's forced the whole country's residential building industry to think about what they're doing, and scrutinize thoughts that we haven't thought, or scrutinize thoughts that we just took for granted. I mean, when I design a house, even if I have done 5 of them that are similar, I still go through every question in the house and say, am I still doing it that way that I did on the other 4, or is there a way to improve it? And we just did a house down in Rhode Island where, working with the builder, we found a way to improve it.
Yeah, because the technology is always changing. You got to keep
up. New
up.
materials, companies coming on with new technologies, new ways to understand materials. It's incredible.
Well, how are regional trends in new technology? Do we see similar things happening, say, in the South or the Midwest, or?
It's very different, because they have different heating and cooling needs. And Steve could probably address this better. But when you're building a house, I just got back from Florida. When you're building a house in a hot, humid climate that's hot, humid year round, you have to think differently. You have to have a different understanding of the building science of what's happening with the weather, and before you can create a shell and insulate that shell to create a healthy indoor environment.
Yeah. What are your thoughts on that, Steve?
Yes, there's 6 climate zones, 7 climate zones in the country, if you include Alaska, and every one of those climate zones require a slightly different way in thinking of building, because things like moisture, heat, and they move a lot differently. But you also have some climates in the country that are somewhat of a mix. If you take Minneapolis and Boston, for example, we have very cold winters, but our summers are as bad as Miami. So part of the year we work like Miami, part of the year we work like Maryland, and then part of the year we work like Boston and Minneapolis. And so you have to develop a house, that can handle that spectrum.
Going back to the passive solar house, Steve, can you give us some examples of how these houses differ from conventionally built homes? What are some of the differences?
So some of the major differences is, one, there's an air tightness requirement. So there's a lot of builders and a lot of professionals out there that say, "Oh, houses need to breathe." That was a mantra for the longest time. Now it's that mantra is houses don't need to breathe. You want to build them as tight as you can, but then you want to include mechanical ventilation. So by providing that hole, if you will, I'm providing a hole that I can filter, that I can condition, that I can treat, and that I can put the air where I want it, as opposed to a house that's 20 or 30 years old that's just leaking everywhere and bringing up dust and stuff from carpets through little holes, making people maybe not so healthy.
So I'm just thinking, because we've all heard this, the house needs to breathe. So what you're saying is you can really control that environment within the house. So if, let's say you have somebody who has really bad allergies, you can control that.
Yeah. Although it's not documented and there's not many doctors that are going to say that, oh, this house is making people healthy. We have done houses where people's health has improved in areas of asthma and stuff. The best analogy I can give is think of your own body, right? We have dedicated inputs, dedicated outputs. Our input for air goes right to a filtration system. Our house should do exactly the same thing.
Yeah, very early on, I think first time I met Steve, I said the same thing to him. I said, okay, well, what about these people that say the house has to breathe? And he goes, well, do you breathe through your skin or do you breathe through your lungs? And when you create a tight building shell, you're basically creating the skin enclosure on a house, a tight enclosure, and then you give the house lungs.
We are talking about green technology. We're going to take a quick break, and we'll be back after this. You're listening to The Point. We are talking about green building technology with Roe Osborn, senior editor at the Journal of Light Construction, and Steve Baczek, a registered architect who specializes in energy-efficient and environmentally responsible homes. 866-999-4626 is our toll-free number. If you have a question or you'd like to join our conversation, that's 866-999-4626. Our email address is thepoint@capeandislands.org. Steve, before the break, we were talking a little bit about the differences between conventional built homes and passive homes. Are the interior spaces of passive solar homes, do they look like the other homes? I mean, can you tell when you walk in one?
Not really. I mean, one of the things I pride myself on, and that we spoke with Roe and builders about, is that these super energy efficient homes really don't have to look any different. I mean, in the 70s, we have these bad connotations of what solar homes were, and they failed, and we have all these bad memories. But this latest set of parameters and understanding has given us a way to just build houses like we normally would, just build them a little better.
All right. So for those of us who already have a home or building, is it too late to improve? I guess we can improve efficiency, but do you work with clients with deep energy retrofits? I mean, can you explain what that even means?
Yeah. So a deep energy retrofit is when you're taking an existing house to the depths of, say, a 60, 70, 80% reduction in energy use. And that is a much harder monster to deal with. Mm-hmm. I have done, about 4 years ago, we did the first passive house retrofit in the country. So we took an old house and reconditioned it to the passive house standard.
Did you have to gut it?
Yeah, pretty much the wall system. The inside we didn't have to gut, but the exterior wall system. So if you think about it, we took a house and we kind of ripped off the T-shirt and put on a heavy down jacket, if you will.
So if a deep energy retrofit seems a bit overwhelming, what are some other ways we can take advantage of technology to reduce energy consumption of buildings?
When it comes to remodeling, and this is true of new construction too, but I basically break it down into 4 simple arenas. We have air tightness, we have thermal control, we have our windows, and we have mechanical systems. Windows out of those 4 is probably the most expensive to replace or redo. But air leakage and thermal control are very low-hanging fruit, especially the worse your house is, the lower the hanging fruit is. I mean, some of it's laying on the ground. So, you go in your basement, and if you can see daylight, grab a can of expanding foam from Home Depot, and wherever you see daylight, make the daylight go away. And I mean, you're stopping that cold air from coming in February.
Yeah.
I've got my cans of foam, and I'm looking at my crawl space with 18 inches of space to crawl to the opposite end of my home. I'm going, but yeah, it's true. There's so much can be done, and sealing around windows. People from the inside, people don't realize that there's so much air leakage that happens around the window, even an old window. The window itself might not be leaking nearly as bad as the space around the window. And it's not just a matter of taking off the trim and trying to poke in as much fiberglass as you can around the window. There's so much more that involved in it.
The problem, the biggest problem I see in the whole residential construction industry, Mindy, is that we have this understanding, we have the knowledge to do better, but some builders, some architects, some developers still choose to build problematic houses. I mean, in New England, we have over 300 years worth of housing stock. We have thousands of houses that are a huge energy penalty and a huge weight bearing on energy efficiency and environmentally friendly status. And we still continue to build those houses.
Yeah.
And we really need to just rethink what we're doing individually as the homeowner, builder, the developer.
Right. What about the builders? Because, it isn't like you've got this building school. I mean, I guess you got kids who learn it from maybe their families or a vocational program. And so how do you educate builders to all these options, which are constantly changing?
Yes. I mean, there's conferences out there, but now times are good. Builders, they can't get away. I tell some builder friends, hey, why don't you come down to the conference here with me? It's like, I can't leave my guys. I'm too busy with work, and it is tough. But the industry is trying to provide, and me personally, I'm working with some people in the industry to develop some type of training regimen that we can, take around the country and work with people to start thinking about what they're doing.
There's so much to it. There are so many details. It's so much more complex than it ever was before. I mean, it's before you build the 2x4 walls, put the plywood on, throw the windows in, throw the siding on, and
voila.
and hand them the key.
Well, 100 years ago or 50 years ago, you're buying oil for 10 cents a gallon. You didn't care if it went out through the roof.
But now when you're doing that, even on a house where where you're trying to go for the D level, the code level of code, you still have to have drainage planes on the outside of the house underneath the siding. So if water gets through the siding, it has to be able to find its way out without rotting stuff away. Which means at the windows, there's a very detailed protocol about how all that happens and to make the water shed around.
Yeah,
people just don't understand, and Steve said a lot of that it's education.
Right.
JLC, the Journal of Light Construction, where I work, that's part of what we do is try to educate, but have articles that explain these small details so people can
start thinking that way.
Exactly.
Yeah. Let's go back to the homeowner who's going, I don't think I have a lot of leakage in my house, and I think people would be really surprised. You can sign up for free energy audits with Cape Light Compact to find out, if your business or your home needs improvement. And I did this, and I think I need to do it again because it was at least 10 years ago, and I was really surprised. I thought my house was pretty tight, and they had these great programs that I got to insulate some more, and it was amazing how much the improvement that
happened.
If
you take your average house, if your house was built probably more than 20 years ago, I mean, in the winter you're effectively leaving a window open.
Yeah
I mean, there's that much leakage, if not more.
I just signed up to have mine redone. Back when I had mine done about 10 years ago, they just looked at my energy usage. They didn't really look at how well insulated the house was. And I just signed up to have it done again. And I'm on a waiting list for them to make an appointment.
I was going to say, in this time of year, it gets tough. But it's something to put on your list, your to-do list, because,
Certainly.
Get on that list because it's worth it in the end.
I mean, most of the building scientists that I run with, their first thing is always, you have to understand where you're at before you can understand where you're going.
Right.
Exactly.
And that's what these Mass Save and the Cape and Light is doing.
Yeah.
They're coming out there and saying, okay, this is where you fall on the ladder. And then you can decide how you achieve success from
And
there.
some of these will have actually programs to help you achieve that,
Certainly.
like discounted,
Exactly. Yeah.
whatever.
Certainly.
And going back to windows, we talked about windows being the most expensive, and yes, they are. But you don't have to replace them all at once. It's like, I know somebody who paints their house like they paint one side a year. So like you're always kind
So
of
it's just an annual routine.
Yeah, so maybe you do that with your windows. You replace one side and then, or one room.
And when we're doing remodeling projects, we do that. It's, we pay attention to say, okay, if we're remodeling this third of the house, let's not just put in the same stuff that we have that's over there that's problematic. Let's put in some other stuff, and then we'll get around to changing that stuff out. But it gets to that whole decision-making process that you really need to understand what questions to ask and get those answers.
So what does the term sustainable construction mean, and what are some of the techniques and materials used that make construction sustainable?
Yeah, so my colleagues, the first thing they're going to tell me is no construction is sustainable, because the minute we choose to build, we're changing and we're inducing the effort to use some type of resources. So if we can get by that hurdle, then the question is can we build a house that has the smallest amount of impact possible? And how do we achieve that? Well, energy consumption is certainly a huge impact, especially if you're talking about a house that's going to be on the ground for the next 150 years. The materials that go into the house, where do they come from? How are they manufactured? Some materials take an immense amount of energy to be created. And are there alternative materials to do that? Can we get products with recycled content that can also be recycled when this house gets dismantled or remodeled?
And just as overwhelming as some of this sounds for the builders, for the homeowner, think about all the choices and, so what's the best way to find builders who practice sustainable construction or who are knowledgeable in letting you know what your options are?
Ask them.
Ask them.
Yeah,
no, I was going to say, I was thinking that when you were saying where things come from.
It's funny because that's kind of a two-sided coin, because people, while I like to have builders that know what they're doing, and when we're doing a new house, people say, well, I have this builder that's a really good friend of mine, Charlie, and he's going to build a house, but he's never done anything like this before. And I tell them, I don't care if he's ever done it before. As long as Charlie's a semi-intelligent guy with a great heart and a good will, then we're going to make this project happen. Because only one of us really needs to know what to do. The other one just needs to understand and have his heart in doing it.
And follow the instructions.
Right. Sometimes I run up against some builders that have done things, and the things they're doing I don't quite align with. And now there's a little friction there because they want to do things their way, and I don't quite believe those to be successful. So knowing is not always the best, but you need somebody on the team that understands it. And with the internet, you'd be surprised at how much homeowners, sometimes they get some of these myths and they bring them to the table in our design meetings, and they say, well, this guy down in Maryland said this, and I read this article in JLC by this guy, and he's telling me to do this, and you're saying do this. Well, okay, but here's why I think mine works, and so you need somebody that has that understanding on the team.
And I like your idea of ask them, Ro, because I've done that where it's like when I was putting some counters in, where does this come from? And one guy I was asking said, I don't know. And the other guy, without my asking, said, and this comes, this is where it comes from.
Yeah, one of the things that I've been impressed with, I've been to many of Steve's seminars, and one of the first things he says is there is no silver bullet for any of these designs.
866-999-4626 is our toll-free number. Our email address, thepoint@capeandislands.org. More after break. You're listening to The Point. We are talking about green building technology with Roe Osborn, senior editor at the Journal of Light Construction magazine, and Steve Baczek, a registered architect in Massachusetts who specializes in energy efficient and environmentally responsible homes. 866-999-4626 is our toll-free number if you'd like to join the conversation. 866-999-4626, or you can shoot us an email, thepoint@capeandislands.org. Before the break, we were talking about the practice of sustainable construction. So for those interested in sustainable practices and materials, are there particular building materials that should be avoided, either because of how they're produced or because they aren't made from ecologically friendly or sustainable materials?
There are. So in an effort to develop yet another building standard. There's one out there called the Living Building Challenge, which really hasn't taken on any great success at the moment just because of its challenge and the professionals trying to understand exactly what it is. But they actually have adopted this kind of blacklist of materials that you cannot use in the project as part of the design of the project. Passive House, in their set of standards, they do have a set of restrictions, if you will, where they place certain parameters on different materials. For example, I'm doing a house right now. Homeowner chose some carpet and the pad, and we had to vet it against this list. And the padding, the carpet made it, but the padding didn't. So we had to swap to a slightly more expensive padding to make it through.
And the options, I mean, now I'm just thinking bamboo has become really popular, bamboo floors, and because it's, I guess, sustainable. And it has a lot of good qualities, right? I mean, it doesn't have the mold or the bugs or the things
It does, but I tell everybody, I mean, all wood's somewhat sustainable because we can grow more of it. And we probably have more wood now than we had 200 years ago.
Yeah.
What about the notion of using locally sourced materials? Is that possible in this region? If so, what are some examples of what kind of materials?
Certainly. And that's before when I was talking about the immense energy in constructing certain materials and manufacturing certain materials. There's also the transportation energy that can get put into the equation. And all of that we term as embodied energy. So there's amount of energy that gets placed upon a product to have it manufactured and delivered and installed before the product starts becoming its own bearing. And there are. I did a project on the North Shore of Boston, and the homeowner did a bunch of the homework. And we locally sourced. We found a guy about 2 miles away that took old shower doors from houses that were getting wrecked or cut-offs from shower door companies, took the glass, ground it up, reformulated it into countertops. Wow. And when I tell you the countertops are beautiful in their bathroom, and it was made a mile away from a wholly recycled material.
Those they're beautiful, those glass counters. I've seen some. They're really beautiful.
A lot of it, too, is managing the waste in the building process. I've been amazed at some of the job sites I've been to around the Cape, where it's just the typical thing is huge dumpster after dumpster after dumpster filled with lumber and pieces of foam and what have you from the job site. I've also been to I was at the Passive House in Rhode Island that Steve worked on, and you could fit the amount of waste from that project into the trunk of my car. Wow. And I've got a small car.
How do you do that, Steve?
Well, some builders, I mean, it comes down to proper planning, and it's that whole buy-in issue that everybody on the team has to believe that this system can work and strive to take their part of the project and make it work successfully and organically as a whole to the success of the project. And that builder in particular, I love working with. I'm working with him on a project right now. But he's very conscientious about, okay, if we cut a piece of wood, we don't throw the scrap into the dumpster. We put it off to the side because that 2-foot scrap can become an 18-inch board somewhere else in the house. And then we throw it away as a 3-inch board, not as a 24-inch board.
Wow.
And he did. That guy got the entire crew to buy in. I mean, these guys who are just like the guys I used to work with on the job sites, they're recycling all their soda bottles. The job sites are immaculate, and they always put stuff there. They always have a place to put everything.
Let's talk to John, who's giving us a call from Orleans. Good morning, John.
Good morning. This is not to distract from green energy, but it's more like yes or no question. What about toxicity of building materials? There's a lot of materials that are toxic. Paints, plywood, formaldehyde, vinyl, etc. Is that incorporated? Is avoiding that incorporated in your green energy?
Most certainly, John. And the thing that makes those even more important is when we talk about an airtight house and providing provide the proper ventilation. But the last thing you want to do is bring in any toxic or poisonous gas with these materials. So we do have to pay attention, and most manufacturers, although it's a slow moving boat for them, but they are moving in a positive direction to get rid of that because we need to. Because one thing we're not going to do that I tell builders is we're not going to retract in our building standards. They're only going to get harder, they're only going to get more difficult, and they're only going to get better. We're not going back to the way we used to build in the 50s. Yeah. So get on board and start figuring it out with the rest of us.
Yeah, John, thanks for calling. That's a really good question. I hadn't thought of that one, but it's a very good question. There are all sorts of gadgets that can sense when you're home and respond accordingly. Smart lights, smart thermostats. So how do these technologies work, and are they worth considering? You're away from the home, and you can turn your heat up with your smartphone on the way home, whatever.
Coming from someone who still has a dumb phone, I look at all these things, and I have about the smartest thing I have in my house is a programmable thermostat, which that was from technology probably 6 or 8 years ago. It's amazing the stuff that the new technology actually learns your habits. So if you live in your house for a couple months and you're turning the lights on, turning the lights off, whatever, the new technology learns what lights you're going to need when, and also when you go away, it automatically mimics a typical evening in the life of Roe, which I haven't gotten there yet. But
that's the way we're going, right?
Oh yeah, and to be able to dial up on your phone to preheat the oven before you get home or whatever, I'd probably forget that I did that and get home and my oven will have been going for 4 hours. But it's just amazing. There's lots and lots and lots, and it changes every day.
Yeah.
It does. The only thing I'll add is I operate on the other end of the spectrum. I tell my clients the hardest thing you're going to find in this project is the ability to be simple, because you're going to want to complicate it. Everybody that we get involved with is going to want to complicate it. Someone's going to introduce gadgets. Someone's going to introduce this stuff. And all I can say is the more specific you are with any of your answers to any of those questions, when they break, the solutions become very specific and costly because of the specific nature of the problem.
Good point. Yeah.
The more general and the more simple I can make it, the simplest it is.
Yeah. Can the principles in passive homes and sustainable construction also be integrated into business or industrial buildings?
Certainly. And one of the current movements, I mean, it's pretty much taken New York City by storm. Passive House down there, just because of New York City versus kind of metro areas, they're doing high-rise passive apartment buildings, 10, 20, and some are planned to be even larger, where it's really taking on. And the good thing is, given the size of those projects and the poor construction techniques that are even worse than our housing techniques, that you're able to create a really good building at not much more cost than you're building the lousy building for.
How do they integrate air sealing and stuff like that in those big buildings?
It's the same parameters. I've never done one, so the specifics. One of the things I know that is a challenge is one of them is not only how do I do it, but then how do I measure it? Because effectively in a 10-story building, I might have 40 apartments, which is 40 houses stacked on top of each other. That the 40 houses all have walls to the outside, but they all have walls to each other. So if you go in there and measure any one of the apartments and it's leaking, where is it leaking? Is it leaking to the outside, which is a bad thing, or is it leaking to my neighbors, which might not be a bad thing if they have their heat up?
That was the question. I mean, we measure individual homes with blower door testing and to test air leakage. So do they blow a door each apartment?
No, I don't think so. I think they have a way of doing it. And like I said, I'm not that familiar with. One of the things that I can speak to is, in Europe, where this building standard has come from, they're doing hospitals, schools.
Oh, wow.
I have an architecture friend that she owns an architecture firm, and they just recently did a Montessori school to passive house standard. So these things are pretty, they're building technology. They're building technologies in the sense that you're battling Mother Nature. Mother Nature doesn't know the difference between a hospital or a school or a house. Mother Nature just sees it as this is basic physics.
Yeah.
And if I solve for the problem, then I solve for the problem.
I think a lot of our listeners have heard of LEED certification. So what are the LEED certifications, and how do they differ from the passive home certifications? They're two different things?
Yes. So LEED certifications is basically, a checklist that developers or builders can use, or designers, to get certification. And the certification is, I believe it's silver, gold, platinum. I have, I don't know, probably about 60 or 70 LEED platinum homes under my belt, which in some ways it's easier to achieve than the passive house standard because of the way they set up the system. It's this checklist system, and some things you can get points for by if you put a development close to a bus stop. Then you get a certain amount of points for that. But one of the downfalls there is while it's improving the way we think about the building, it's not improving each structure directly. Passive house deals with each structure individually and gives you a pass or fail grade to that one structure. But LEED, I mean, you have to start somewhere, and you have to do something. So if using that LEED checklist is your way to get a better understanding and climb that ladder of success, then I say go for it. It's better than building at the bottom.
What about the size of the structure? The tiny house movement has picked up traction in recent years, but even if people don't want a tiny house, could scaling down a home reap benefits energy use to both build and maintain?
I mean, you could have a tiny house that made with screen walls. It's pretty. I mean, that's an exaggeration, but it's how you build the walls. You can also have a very large house that's.
It's much easier to build a very large, energy efficient house because I have leverage. I have volume in that house. Smaller houses are much more difficult to hit the air leakage numbers, etc. But I'll give you a kind of a hard number example. The house that's about a mile from here is about 2,600 square feet. We heat it with one mini split. The mini split is that wall-mounted. One mini split, and it's that wall-mounted unit that most people were putting those in their family room as a retrofit. And this gentleman is heating his whole house and cooling his whole house with that one mini split. And his house is 2,600 square feet.
Wow.
So big house, little house, again, it's how do I put all these decisions together, and to what level of success am I striving for? And that one is a certified passive house. And because it has met that standard, then it's in a position to reap those benefits. So as an elective, the homeowner chose to put a solar array on his roof. And this is the one that now he pays. We had his house, his 2,600 square foot house, down to about, I think it was like $150 a month for heating, cooling, hot water, electric, cooking, plug load. That was his energy bill a month. And then we took that $150 a month and just wiped it off the table by putting a solar array on his house, and now he's paying for his sister-in-law.
That's amazing. We're going to put links to both your websites on our website, capeandislands.org. Steve Baczek and Roe Osborn, thanks so much for coming in and educating us a little bit on passive solar homes and green technologies. Appreciate it.
Thanks.
No, thank you very much.
I'm Mindy Todd. Thanks for listening.